Hi everyone, my name is Mike Milner and I head up product management for our Cloud One platform at Trend Micro. A big part of my job is talking with customers to understand their business, their processes, and how they structure their teams, and how the different people in the organization work together to improve their security. By understanding how different parts of an organization work together, we can build platforms that align well with how customers work and identify new ways we can help with security. I want to talk to you today about 3 key functions involved in security and how they work together to solve real-world security problems. And I'm going to start with the Security Operations Center. When most people think of the Security Operations Center, or SOC, they think of a large mission control room, kind of like you see here. And in some organizations, this is exactly what they do look like. This is the AT&T Global Network Operations Center, which also handles their security response. So while it might be a room, I think of it more as a business function. The SOC detects and responds to security incidents. Usually, the SOC pulls in information from across the organization using specialized tools, bringing together information from desktops, laptops, and other endpoints, including data centers and networks, and more recently, cloud environments. At a high level, the goal of the SOC role is to detect threats that may cause harm to the organization, and to respond to those threats to reduce or prevent that harm. And finally, they need to build understanding of those threats to help inform overall security activity, basing it on real threat intelligence. Historically, detecting threats is usually focused on network monitoring. With private data centers, attacks would have to come in through the network, and any data exfiltration or command and control type traffic would have to leave over the network. With the rise of cloud computing and employees working from home more often and using their own devices, this singular focus on the network doesn't really work anymore. A modern SOC needs to analyze data from many different data sources to understand how systems are being used and by whom, to identify abnormal activity and separate it out from the expected normal activity. In order to do this, a modern SOC needs access to a huge amount of telemetry from many systems. I'm going to focus today on data from cloud service provider environments, but that's just one part of the overall picture that a SOC would be looking at. Responding to threats has also evolved considerably with the rise of cloud computing. With a network-centric view, responding to a threat usually involved blocking things on the network. Today, this form of isolation is still a common way to contain threats, but for many types of attacks, this isn't really effective. A firewall rule can't stop an attacker from calling an AWS API, or block access to an S3 bucket that maybe was left publicly readable by accident. Newer types of threats need other ways of responding. From a developer perspective, you've got a security team looking out for the integrity of your application, which is great, but the SOC can only see what's going on based on the information it has access to. And this brings us to the next role I want to talk about in our story, the Security Operations Team, or SecOps team. I always find analogies can be helpful to explain these concepts. You can imagine your organization as a big fortress or a castle, and there's an opposing force, the attacker, marching across the field trying to get in. The SOC that we just talked about, they're kind of like the defenders up on top of the walls. They're looking out all the time for attackers, and when they see them coming, they defend the walls to keep them out. And if any of the attackers do manage to find a way in, They track them down and get rid of them. And importantly, figure out how they got past the walls in the first place. It's not an easy job. The SOC is very busy. The security operations team, in my analogy, they're the ones who build the walls. If you don't have walls, the defenders can't keep the attackers out. The SOC is busiest during an attack, protecting the castle. The security teams are busy all the time, building those walls, making them higher, thicker, stronger, filling in holes and other gaps, making the castle more secure, harder to attack, just like they do in your organization. So the security team supports the SOC by ensuring they have the resources and information they need. Security teams constantly assess security posture, looking for new weaknesses, incorporating threat intel from the SOC's own investigations and other public sources, and using that to proactively improve defenses. A key role of the security team is to understand what developers are building, to anticipate what possible new threats could be introduced. By understanding the types of threats that are expected, different response techniques can be developed as well that might be specific to different applications or different use cases being produced. The security team also typically establishes policy guidelines or guardrails to help development teams follow best practices for security. Everybody cares about security, but it might not be a top priority for developers. It is for the security team. And they are really there to help the developers be more secure. And that interplay between developers and security, it hasn't always been the greatest in most organizations. A traditional security team usually acts as a gate. In order to deploy something to production, it had to go through some security process. It's usually at that point that security could see all the details, ask questions, and kind of act to decide if something should be allowed or, in a sense, sent back for further work. In more modern DevOps workflows, that really doesn't work. It's too slow. And speed is the name of the game for DevOps. As a result, security teams have kind of lost a lot of that visibility into the development process that they had before. Modern tooling like containers are even designed to support this isolation. Developers can put whatever they want into a container, and whoever runs the container, whatever infrastructure runs the container, doesn't really need to care what's inside. Cloud accounts have done largely the same thing, but to entire application architectures. The cloud account isolates resources, so you don't need to know what's inside one account when you're working in another. And that has huge advantages for speed. No need to coordinate work between teams since they're working in isolation, which is great, except it also means that security teams, by default, have almost no visibility into what's going on inside these accounts or inside these containers. And that brings me to the last group I really want to focus on today, the developers. Developers have a lot of responsibilities as part of delivering the software to users. Today I'm going to talk mostly about the security aspects of the role, but of course that's just one of many, and why often security isn't the number one focus, perhaps, of development teams. So my number one advice here to developers is really work with security teams early and often on every project. The chances are high that you'll be using some kind of new technology that the security team might not even be familiar with. This is pretty common when you're adopting new technologies. Spend the time with them to go over the details. Help them understand where the differences are compared to other technology your organization may have used in the past. The time you spend with them up front makes everything easier when you're getting ready to go to release your software, because you're usually releasing very often in DevOps. It also really helps with the visibility problem I was just talking about. If you're using new frameworks or languages, work with the security teams early to make sure that the security tooling will support what you're using. And on that tooling, work with your security team to help them deploy and integrate the tooling. Of course, we're all here at SnykCon, so we believe in using automated tools to help developers build secure software. Whenever possible, use the same tooling in your development as your security teams are using. That really makes sure you've got the same view on the various bits of threat information that you have, so you can have meaningful conversations with the security teams. Everyone wants to be secure, but kind of as I've outlined here, different teams have different perspectives on security. So what I want to do now is look at a few real-world examples to see how these different lenses or different aspects play out. As a developer, you might be thinking about security in terms of bugs in your code, or maybe a third-party library like this top example here. This is actually an example, in this case, of a connection string injection vulnerability, where an attacker can override some of the connection string parameters through injection, in this case, to weaken some security protections. Very low level, very detailed. As a CISO, you might think of risk more in the terms of the bottom example here, a headline in the news. Nobody wants to see their organization suffer a breach. At the top, a CISO has responsibility for an organization's information security as a whole. And that responsibility cascades down through the organization. But to really support that, it also means that the visibility into security aspects needs to bubble up from the work the developers do all the way up through the security teams with visibility to the SOC and all the way up to the executives. You might not recognize this. This is a CVE reference. And if it was March 2017 and you saw this reference come up in some scan results, you might not think much of it. But you probably do remember the headlines a few months later. I don't know what information was available when for this organization, but it really does serve as an example of what can go wrong if information about risk isn't communicated and put in the proper context, of overall organization risk. This example here is similar, but I want to consider a different aspect. In this case, the Python package repository was seeded with some malicious packages that replicated other popular packages, but with a small misspelling in the name. The malicious package worked just like the original, but included a small bit of malicious code that sent some information to the attacker. On the surface, this looks clearly like a developer problem. You shouldn't have misspelled the name. And yeah, that's easy to say, but mistakes do happen. And when we talk about risk management, we have to work within the real world. Now, we've talked about how developers can help security teams. This case is a great example of how security teams can provide cover for developers. Automated tools might struggle with detecting a new package like this that has intentionally vulnerable code, but is explicitly requested by the developer through that misspelling. Until it's known to be vulnerable, it's more difficult to give relevant alerts. But security teams and the SOC have other tools that they use, other tools available. In a mature security environment, it's very likely that network traffic in and out of your environment is being monitored. If a malicious package like this is making new outbound requests, sending that information out to an attacker server, this is something that those networking tools are really designed to detect. And it's fairly easy at that level to block those outbound requests as well. So even with a developer mistake, this misspelled package name in this case, the organization can remain secure by these controls, that blocking of the bad network traffic, these controls introduced at the networking layer. Typically, if this happens, the SOC would see that, they'd implement the control, and then they'd be investigating to find out where these requests are coming from. And this investigation will likely involve the development teams as it kind of investigation reaches their environment. And eventually the misspelled package name will be discovered and kind of corrected. But the key thing with this process is that the original detection and that response, blocking that network traffic, gives the development teams time to investigate, time to implement a proper fix, and time to actually get it deployed. This is a great example of how all of these teams working together can really effectively protect an organization. And after the full cycle, after that remediation is complete, the security team may then take that information, those learnings, and adjust overall security policy to make these classes of attacks less likely to succeed in the future. By incorporating this feedback, learning from attacks, it really raises the bar on security for the whole organization. So that all sounds great, but to get to that level of collaboration, to get that collaboration going like I've described, you need to work on a few things, a few key aspects. First, you do need to invest in that common tooling I mentioned. If the security teams can't see the same threat information that developers see, if they don't have the same visibility, that same context, then they can't really effectively manage that risk. You also want your tools to understand the development environment. A great example of this that I run into as a developer is in testing and test automation. As a developer, you might want to run some tests with a known vulnerable library or an out-of-date library. You need to be able to somehow mark that in your development environment so that other developers understand the context. But you also need that annotation there so that security tools understand what you're doing. Otherwise, you'll keep getting false positives about this library, even though that's something that you're doing intentionally. This concept of common tooling is also important in the other direction as well. With a lot of security tools, looking over your environment and understanding your environment, you want them to plug in where you're already working. If you're already storing your source code, say in GitHub, then if you've got tools that scan your source code, you want them to just integrate with GitHub. You don't want to have to bundle up and upload separate copies of your source code to separate places so they can be scanned. It's much better if it can just be scanned in place. If a security issue is discovered in production, instead of a manual email sent to somebody by a security team, maybe just have the tool open an issue directly in your Jira system or other issue tracker. And if it's a critical issue, something ongoing, maybe open an incident and kind of kick things off in PagerDuty to get immediate attention. By using common tooling, the tools that you're already using, it makes it much easier to collaborate with security teams. And when security becomes part of your normal processes that you're already using for development, instead of something separate, which is seen as slowing things down or intruding on your flow, you've got more of a seamless flow with security being part of the process. We've seen how these different teams approach security and how they look at security differently. These different lenses on security are really a good thing. Different teams focusing on different aspects of the overall security picture. When they work together effectively, it makes a powerful, iterative approach to improving security for an organization. That level of collaboration is a huge challenge for many organizations. With the rate of change really continuing to increase on all fronts, it's important to put in the effort to get this right. At Trend Micro, this is a huge focus for us, helping our customers manage and improve this collaboration. We recently launched a new product capability in our Cloud One platform in partnership with Snyk. Trend Micro has a strong background working with security teams and the SOC. Partnering with Snyk on this new open source security component brings more of that common tooling, leveraging Snyk's experience with developers and their experience with that common language and understanding of development environments to look at open source vulnerabilities to help quantify that risk. By making it a part of our Cloud One platform, we help to integrate all of those runtime controls I was talking about in containers and network and workload and cloud environments across all of these different technologies. We marry that with the visibility of development security. Again, really building on that theme of the common tooling and collaboration for a better overall security policy and security posture. If you want to learn more about these collaboration aspects between security and development, or more on our partnership with Snyk, you can find more information using this top link here. If you want to try out the Cloud One platform, including our open source security by Snyk component, you can get a free account using the second link here. Thank you very much for joining me here at SnykCon, and please enjoy the rest of the conference. Thank you.